All right, let's come together. Does anyone have a really good example of a chart that either like just friggin' nailed it or just missed the mark? You have one? Okay. Can I search it somehow or?
Yeah. It's theflowingdata.com.
Okay.
Oops.
Theflowingdata.com.
Yeah.
Okay. All right, and
No, I think probably search it by something like I don't know how to put it. It's the American Time Use Survey.
okay, so the American
Time Use Survey data.
Time News Survey data. Is that
Time Use Survey.
this? Is like this one right here?
But then it's by theflowingdata.com.
This guy?
Oh,
Or was it like Day in the Life of Americans?
yeah, that one.
This one?
Yeah. Maybe keep scrolling down. Yeah, this one.
Okay, cool. Okay, so walk us through this.
So,
And let's be quiet so that everyone can hear, yeah.
yeah, so it just represents the different categories of people, whatever they're doing, what kind of action they're doing at that point of time.
Oh, I see. And
If you fasten the data, yeah, so you can see people just moving around. By 5 a.m. people start waking up and they do different actions. And this is based on 1,000 people in the US.
so work is starting to build up. Housework's happening, kind of a big mix of that. Personal care, eating and drinking. Yeah.
But one downside is that they don't represent the legend. They just think that we can understand from the circle that each of the circles belong to the categories that are represented.
Okay, cool. Yeah, and it can be a little bit messy. Like this definitely doesn't give us a quantitative idea, but in broad strokes, it's kind of cool. This is a nice time varying one, actually. I like this. So do you have specific critiques or specific things that it did well?
We just thought a legend on the side, like this purple color represents this activity because it keeps moving and we are not able to judge what is the color of what activity.
Well, what's interesting is that you've got the activity is dual encoded, right? So dual encoding means that you've got the same variable is represented in two different ways, which reinforces it. It can make it less cognitively demanding, and if you don't see color, for example, you can then just see location. But this allows us to kind of see that, like, okay, like there's a smaller work now because we're into 8 p.m., so we're now in leisure time mode. It does give a kind of sense of like flow, so we actually get to see the rate of change in addition to the size. But the fact that like yellow is sleeping, but also it's like all in this location, I think really reinforces that's what's there, right? I'm not sure you need a legend is almost always a great thing to have. In this case, I think it's interpretable enough because it's dual encoded, but it's reinforcing. But yeah,
I
yep.
think in this graph is really good at like what it's trying to do, like increase the statistics of quantity and
Yeah.
what is trying to
And it's tricky. Like so, here we have motion as a variable, right? Motion is kind of the rate of change. You get the color changing and kind of move its way out. It does give you a sense that like the physical collisions that are going on does get in the way of it a little bit. So that's maybe my criticism is that you see like these people are trying to wake up and then they lose and yeah. So it does kind of muddy it a little bit, but. Cool. I think this is generally a good example of a visualization. It's very complex. It's probably beyond what a lot of what we'll do in this class. But people had asked about a final project. We'll keep the final exam, but I'm considering whether we can add a final project to reweight some stuff as sort of like a bonus or optional thing. And if so, like an interactive visualization like this would be a great final project. So, okay. Does someone have an example of a terrible graph? Yeah?
I searched global warming graph and searched on the Google.
Okay.
I took the first example.
This one?
Yeah,
All right, walk us through this.
so this is the data of CO2 emitted worldwide from 1860
Where?
to 2000. 2014.
Where is it? This one?
Yeah.
Okay.
And it's a good graph because it's trying to show the general trend that CO2 emissions are increasing.
Yeah.
But in the previous model, like it doesn't have any grid line, so I'm unable to locate at what point, like if I want to find out between 1960 what is the global emission there, I would have to track it down as well.
Okay, yeah, so it doesn't let us query, so we don't have the details on demand, and that would be kind of useful. Like, it'd be kind of nice to know, like, we get a sense of the global amount, and maybe overall, like, the rest of the world's about that much, China is about this much, or whatever. It does do a good job, I think, of certain trends. Like, you see, okay, yeah, industrial revolution happened here. We've got, you know, the disproportionate amount from different areas, right? Like, Russia has a larger amount of CO2 emitted during the Cold War, and then, like, you know, shrinks a bit here. China has a more recent development of emissions. So I think these trends are good, but it doesn't have the details. So you're right, you can't do like a detailed analysis on it.
And the other thing is like they have differentiated between developed and other countries, but within the developed countries like European Union and other countries are all represented with the same color. So
yeah, so it's making decisions for us about how to aggregate things. And so that's already like sort of an angle that it's trying to portray, right? And it really is trying to make a case it looks like versus the developed world, so-called developed world versus other countries, right? Yeah?
But in the context of this graph, though, because it's only for years time article,
Yeah.
like the details don't matter at the end of the day. Like it is a perfectly fine graph for the content you're describing.
I think so. Like what this graph tells us, I think, is that like A, we've had a rapid rise in emissions. B, there's different distributions depending on different categories of countries and different like certain countries as well. Like to me, I see mostly a trend. Like there's obviously the trend between U.S. being generally the same as the EU and other developed economies. You see a bit of some interesting stuff about Russia, China, and India, and then the rest of the world's kind of just disregarded. But I think you're right. Like there's certain points you can make with this graph. So yeah.
but won't the bar graph would also be able to provide same information and a little bit better?
Well, so how would you do a bar graph for this?
So like I would treat everything as a different category. So like what is US emitting, what is European Union?
For what time region? So this is good because it's temporal data. I almost said I stand this graph. I'm into this graph because it gives something over time, which is the story that it's trying to tell. So I think it's a very good example of a chart that is, or a graph that's very good at supporting certain things in the article, and you can like see what points they made based off of what they rely on, like what they reference in the chart. But it doesn't serve other purposes as well. Okay, great. So that's good. We're gonna move on. But this is a good skill to have. Okay, so graphing is good. We kind of know how to do it. How do we do it in R? Has anyone made a chart in R before? A couple of you have. Was that from the swirl activities or on your own? Was it ggplot? Okay, excellent. So this might be a bit of a review for those of you who've done this. So we're going to go through this, and then we'll have a nice big break because then we'll switch over to the second half of the lecture. And a 3-hour lecture slot straight through is going to be a lot. Do people need like a minute now to like stand up and stretch, or are you raring to go? You get to switch to. Some of you are like yawning and stretching. Let's take 2-minute break. Get up, stretch, drink some water, and then we'll do the next 20 minutes, finish off, and then have a longer break. All right, 30 seconds and we'll come together. Alrighty, let's come together and let's talk about how to create graphs in R. I'll just wait till we're all a little more focused. We will have a longer break in a moment. So to make plots in R, there are 3 different main packages that can be used. Core R plotting, these are just built-in plots. It's good for very quick plotting. Lattice is a very useful thing for quickly showing small multiples, and so I've often used that in the past as a quick, just show me all the combinations of variables. But ggplot is the most powerful, and it's not much harder to use. Once you have a grasp on the ggplot grammar, you can plot things really, really easily, which is super important for being able to iterate on your graphs. The first time you create a graph, it's going to be terrible, so you need to iterate on it to make sure it's as effective as possible, and to be able to rapidly use in exploratory data analysis. So you can go from insights to probing the data for more questions. So we're going to use ggplot for this course, and so let's talk about how this works. Plots are built up with layers. Okay. The idea is you've got your plot, you've got different layers on top of it. These could be different marks or different kind of aspects of the plot. And then those contain geomes. Those are the actual things that appear that your visual system sees. And aesthetics is kind of this object that governs how the data maps to the geomes. Okay? So plot is constructed by layers of geomes. Aesthetics control graphical parameters of these things. So you can specify aesthetic properties either specifically, so globally, or variably, connected to variables in the data. So you can say color equals blue, or color equals political affiliation, right? And then that might be mapped to certain variables. Red or 2, variables, gender, experimental group, etc. So to get started, you start by loading ggplot2. If you don't have tidyverse, we'll be using that today. So you want to install packages tidyverse and use library to load in ggplot2. And we're going to study this data set called MPG, miles per gallon. So I'm going to do some live coding now, and hopefully I'll remember how to use R. So what we're going to do, we're going to make sure so I'm going to do library tidyverse, just so I've got that installed. There we go. Library ggplot2. I think I've already loaded it actually. And if I type MPG, excuse me, you see we've got some data. Now, this is a tibble. We'll talk more about that in about a half hour. But it's basically just a data frame. So it's a bunch of different types of data arranged in rows and columns. Each of these is a variable. And here we see that this is a character. So this is a string. It's a word. There's a word. This is a double. So this is a value. This is an integer. So it's a number. And then we have different kind of transmissions here. Drive, city, highway, etc. Okay? So lots of different variables here that we can work with. So what are these variables? So for example, displacement. This is the car's engine size in liter and the car's fuel efficiency in mile per gallon. You can actually find these, I believe, by using the help function. So question mark. Here, let me zoom in. MPG. This actually brings up the metadata, which is a very useful thing to have for any data set. So you can see here, displacement, engine displacement in liters, etc. You can also do this by searching in the help function here. Okay. So if you need more information, you have documentation, use the help function like we just did. So let's try to answer a question. Do cars with big engines use more fuel than cars with small engines? When we talk about exploratory data analysis later today and next week, and for your first assignment, you either start with a question or a hypothesis, and then you start to explore that in the data, or you start with an observation in the data, and then you create a hypothesis or a question with that. And you do this very iteratively. So we start by making a plot. You do this through the ggplot2 function. Data equals MPG, so that gives us the sense of what the data is. And then geom_point, and you give a mapping. This is where you give the aesthetic. The aesthetic is given through AES. X is displacement, and Y is highway, which is the highway mileage. And you'll get a plot like this. Let's see how this works. So ggplot2 data equals MPG. And use plus to add the next extra layer on that. I believe we're doing scatter plot, right? We're doing geom point, yeah. Geom point, this adds points. Mapping equals aesthetics. X equals displacement. Y equals highway. And actually, this should be ggplot, I think. Yeah. So that's an error. The package is called ggplot2, so the slides have a bit of an error because I copy and paste things incorrectly. So you want to use ggplot as the actual command, but ggplot2 is the library you bring in. And on the side, you get your plot. Cool. And so yeah, you can follow along if you want, and the slides are posted so you can kind of work on this on your own. Okay. When I do live coding, I'll try and go a little bit more slowly so that people can follow along. But I won't necessarily wait for everyone to catch up. So you got your base plot. Again, that should be ggplot, not plot2. You give the data set, so where do you find the variables in the data? And then with the and then you got the geom. And you get multiple geoms, they stack up in layers. The mapping tells you you give the aesthetics, and you can just use the variable names. So display and highway are in the names, they're in scope, because we know that data is MPG. You can also do this like this. This gives you exactly the same plot, because the aesthetic, once you give it, if you give it in the base plot, it'll apply to everything down the line. So if you have multiple geoms that you add, the aesthetic might affect all of those. Now, of course, we're missing something. What's a critique you have of this plot? So right, the title. We're missing a title, and we're missing the labels on the axes, right? So to add those, you can use the labs geo. And so here you can say the X label is engine size, and the Y is fuel efficiency on the highway in miles per gallon, because I believe this data set is American. So let's do that. So if you press up in RStudio, it brings the last command that you wrote. I'm actually going to take the mapping. I'm going to move this over here. You know what? Actually, no, I'm not going to do that. I'm just going to do the same. So the same command as before, plus labs, X equals engine size in liters. Yep. Y equals, what is it, fuel efficiency? Yep. Fuel efficiency on highway, miles per gallon. And now we've got that. So you can see on the side. And so you note that I've also given the units, so that's really important. And then I've got the unit is here as well. Okay. And that's the outcome there. So adding labels might seem like a small change, same for title, but it's critical for understanding and communicating data as we've seen. So it adds the context of what these variables mean. When I go through my slides, sometimes I'll skip this step, but all the time in a report or whenever creating something for anyone to consume the data or the plot, you want to add in that extra data, extra information. So now that we've created this plot, what do you see? Do we see any trends? Do we have an answer for our question? Yeah.
The efficiency decreases as the engine size increases.
Okay, so as engine size increases, fuel efficiency seems to decrease. Is that what you're going to say? Okay, so we have a broad trend. Is there anything else going on?
There are groups of engine sizes.
There are groups of engine sizes. Oh, tell me more.
So I see a lot of points for a particular value. Like before 2, you see a lot of them.
Right, so like there's a lot like around here. My car has a 1.8 liter, for example, because I drive a Golf. So mine would be in that kind of category with lots of them. Yeah. So yeah, so we've seen some kind of clustering going on. Anything else?
Also for engine sizes above 4 liters, there's not much impact on fuel efficiency.
Yeah, like levels out almost, right? So we see this kind of broad trend, but then when you get to large engine sizes, other stuff is going on, right? One other thing I noticed sort of in that area, so it follows a linear relationship, but there's some points that don't follow this. So we can either, that might be that it kind of levels out on the whole, or there's something else going up in this category, right? So what should we do? What do we think's going on?
Find the correlation.
We could calculate the correlation. I'm going to suggest that we just keep in the visual land for now. We'll talk about correlation in 2 weeks, but we'll start doing statistical calculations next week. So what do we think is going on in that category? So we could calculate the correlation, but I think we should understand a bit more. You know, this seems like there's a trend, but there's other stuff going on, and there's variables we haven't plotted yet. So one hypothesis, and I have a bit of a future sense here. Maybe these points are a different type of car, right? We talked about categories. There's some that are smaller, there's some that are larger, but maybe there's something else going on over here. So I have an idea from what I've seen. So now I go back to my hypotheses, and I add something. You see that right there? Add color equals class. So let's do that. So I'll stretch this out. So I press up again, and then I can just click right here, and I'll say color equals class. Class is a variable. And you can see the autocomplete even comes in. So it'd be like here. Oh, whoops, sorry. And now we have a bit more information going on. Okay? So let me pop back over to our presentation. So that gives us this. So now I have class is here, and you can adjust the names of this, but we'll just leave it like this for now. The ways to do this is through the factor function to actually annotate these factors to have a string that they present that's a bit nicer. Or you could do it in ggplot. But what we see, what do you see now?
Two-seaters are better in efficiency compared to their engine size
And why do we think that's the case?
in comparison to those underneath.
Like SUVs and pickups are kind of, yeah. So why are two-seaters?
They are smaller in size, so less weight.
Yeah, they're sports cars, right? So they have big engines, but it's not a lot of weight. An SUV is big and heavy. A pickup truck is big and heavy. A two-seater has a similar sized engine, but it's tiny. Like a little Miata could just zip, although Miata doesn't have, I think, that big of an engine. So looks like these cars, yeah, two-seaters. They're sports cars with big engines but smaller bodies. So again, we could have gotten the correlation right away, but just from plotting this and starting to understand the different variables, we get a sense that, oh, there is a strong correlation, but the two-seaters are kind of an outlier. So when we look at an analysis, we may want to separate by car class. right? So now we've learned something, like, okay. And the cool thing about this is we have a bit of an answer to our question. Yes, there seems to be a relationship between these two. We could quantify it with correlation or a regression model. We'll talk about that later. But we've done a kind of secondary analysis. And whenever I've done an analysis, the first thing is like, you have a hypothesis, you test the hypothesis, it either succeeds or fails. But that's usually very boring, right? That's kind of the boring, obvious answer. There's usually some nuance in the data that you can follow up on, right? And so doing so lets you get deeper insight and find something that's much more interesting for your conclusion. So you can use different mappings. We can use size instead. So instead of color, you've got size is class. Is that better or worse? It's worse, yeah. Remember that chart of like the visual channels? Size is much worse. It's actually, size is good for continuous variables, not for categorical variables. Some are bad. So it's something to keep in mind. And in fact, ggplot will tell you using size for a discrete variable is not advised. Size is continuous, so you don't want it for a discrete variable. So think about what you graph. So key takeaways from this first lecture. Exploring data is the first step to understanding it. You need to understand what's there before you start to test or conclude. Exploring is visual, but also maybe some of your summary stats. And I argue that graphing data is the best way to start exploring. Looking at documentation and maybe some summary stats are good too, but make sure you look at the data. Summary statistics will be useful, but miss something, and you got to be careful about what and how you plot. So the big takeaway from this lecture is to be able to visualize data using best practices. Okay? Are there any questions about graphing and visualization? Yeah? Wait, which doesn't work, sorry? Oh yeah, there's nothing in there? That works. Yeah, absolutely. So right now I've got the geom point here, but I can actually take this, I can cut it, and I can put it in here. Because when you add a mapping to the base plot, it applies to multiple geoms. And so this will work. And that's the exact same thing. And if I go again and I change this from color, I do size, it again works. So the aesthetic, like the mapping, it can be in the geom if you want it specific to that geom, or it can be in the plot if you want it across multiple plots. And so as you construct more advanced plots, you can change what goes where. And so, for example, you could do color equals class. But in geom point, you could say mapping equals AES. And I think you could say color equals red. And now you've given an aesthetic that just applies to geom. Right? So you can actually put these things at various points in the stack. Other questions? You'll have lots of chance to practice this, so don't you worry. Yeah?
You know the AES function you're using?
Yeah?
How come in your slide, like your slide over here, it says don't use AES for geom, for layers or geoms, but you still use it in this one.
I sure do. Let me make sure I'm giving you good advice.
Yeah.
Oh yeah, I think you can just write in, yeah, sorry, I used it there. That might modify it globally. So I think what I probably should be doing is I think you could just say color equals red. Yeah, so you don't need to use AES for that. I haven't looked in the details yet. Using the AES might modify it for others. So I'm not sure of the semantics. So good point, you should be careful about that. But yeah, you can skip it. So right here, you don't even need the AES. Thank you. Question, other questions? Yep.
Why does this plus sign come like when I'm running the same syntax which is here ID?
So sometimes you'll see a plus sign. So right now I've got this little arrow that says it's ready for the next prompt. But if, for example, if I forget a bracket, I'll see a plus sign because it means that you've forgotten a bracket or a quotation mark. You haven't closed something. So then you have to add in your bracket. Okay? So it means that you have a syntax error and the R thinks that you have more to say for your line. Okay? If you see the plus and you want to get out of it, type Control C or just hit Enter a bunch of times. Hit Control C and it'll get it out. That sounds like a magic thing. It's common in command line interfaces. If anyone's used Unix, it's the same kind of thing. You're kind of exiting that command. I think escape might also work. Yeah, you can press escape as well. Other questions? Okay. We are going to take a, do you think you need a 5 or a 10-minute break? 10. Okay. We're going to take a 10-minute break. We're going to come back together at 5 after, and we'll do some live coding. We're going to talk about manipulating data. Make sure you download, in the meantime, download the manipulating data RMD file, because you can then modify it and code in the file as we move. So it makes it much easier, okay? Okay, 10-minute break. We'll come back together 5 after.